Hello everyone. Welcome to the lecture third of MME2. In the last class we had done 12.4, that was about the scalar product of vectors. We also covered topics like Cauchy-Schwarz inequality and triangles inequality and did some questions based on exercise 12.4. Today we'll be starting with 12.5, which is about lines and planes. So here we'll be learning how to find out the equation of a line and then equation of a plane, right? So let's get started. Okay. So suppose you have a point A or a vector A with you, right? So we are in the space Rn, R3, right? हम three dimensional space में है where we have three axes, x-axis, y-axis and z-axis, right? Suppose we have a vector with us A, which is A1, A2 and A3, and then we have another vector B, which is called B1, B2 and B3, right? Uh, then we have seen that suppose this is your plane, so this is x-axis, this is your x-axis, this is your y-axis, this is your z-axis, x-axis and y-axis, right? And then you have a vector A, right? You have another vector B, and then you say that a line passing through these. So if we take a combination of these, so we had said that x is equal to 1 minus t times A plus t times B was a line joining these two vectors A and B. This we had seen in the last class, right? Now we say that for this was when t lies between 0 and 1, but if t takes any value, right, if t takes any real value, then this would cover the entire line L. So this would be a line L here, right? So for t, so if I take t belonging to the real space, so t, if t takes any real value, then this x, the vector x here, which is 1 minus t times a plus t times b, would would be covering the entire line L here, right? So I can find out the equation of line as x is equal to 1 minus t times the vector a plus t times the vector b. So if you want to visualize in a 3D graph, you can look at it like this. This is suppose this is your plane, right? So this is your plane where you have, this is your x-axis in red, this is your y-axis in green, and this is your z-axis in blue, right? Suppose you have two vectors, vector A and vector B, vector A in pink here and vector B in yellow here, right? If I take a linear combination of these vectors A and B, right? If I take any linear combination of these vectors A and B, I would get another vector x. So if I take a linear combination of A and B here, say x is equal to 1 minus t times A plus t times b, where a is this vector and b is this vector, then I would end up on a point between a and b or on the line L, right? So suppose here t is half, so I would be in the midway between a and b. So my vector x here would be this, right? So my vector x would be this if I take t as half. If I take t as 0, if my t is 0, then you can see from here that x would be nothing but, so if t is 0, then x would be nothing but vector a. So for t taking a value 0, my vector x would coincide with this vector a, right? Similarly, if t takes a value 1, then my vector x would coincide with the vector b, which is the vector in yellow here, right? If I take any other value of t, my vector might lie anywhere on this line. It might be here, it might be here, and so on, right? So these are the, so my vector x would cover all the points on this line. So the equation of this line we can get by writing our vector x as 1 minus t times vector a plus t times the vector b, right? So I hope you are able to visualize it here, right? So let me mark the vectors for you here. This is my vector A, this is my vector B, and x is any vector on this line, right? X is any vector on this line L, right? The line L, and this is called our line L, right? So I can write that the equation of the line, right? So now if I have to describe the equation of a line, now when I have to describe the equation of a line, how will I describe the equation of a line? So this was in three-dimensional space, but then in general you can define a line in Rn, where n is the dimension of the real space, right? So a line in Rn, the line L through A, where A is a vector A1, A2 and so on till An, and B, where B is a vector B1, B2 and so on till Bn. The line is the set of all x vectors, right? So the line is a set of all the x vectors x1, x2 till xn, satisfying the equation that x has to be a linear combination of a and b. So that is x has to be 1 minus t times a plus t times vector b, right? X vector has to be 1 minus t times a plus t times b, and this is for any real number t, right? For any real number t, right? So you can visualize it here. When my t was 0, I was on the vector A. When t was b, when t was 1, I was my x was nothing but my vector b. And when t could take any other value, it would lie, the vector x would lie on the line L here, which is shown in purple, right? So this is any vector x, right? For any different values of t, you will have different x's here, and if you join all those points, you will get your line L. So the equation of the line is here the set of all the x's which satisfy this particular, the set of all the x's which satisfy this particular equation, right? So let's see one question based on this. So let's see an example of this. Let's see a question, right? Describe the straight line in R3 through 2 points. So we are given 2 points, through 2 points A and B, right? Let's see what type of questions can be asked through 2 points. Point A is, or vector A is 1, 2, 2, and B, which is -1, -1, 4. So how will you find the equation of this line, right? So, and the second part asks, where does this line, जो आप equation निकालेंगे इस line की, where does this line meet the x1, x2 plane, right? So what is x1, x2 here? You can either call it xyz plane, or you can call it xyz space, or you can call it x1, x2, x3 space, right? So that doesn't matter. So where will it cut the x1, x2 plane, right? So let's see the solution of this question. सबसे पहले तो इक्वेशन ऑफ स्ट्रेट लाइन मैंने आपको बताया है, इट इज अ सेट ऑफ ऑल दोज एक्सेस व्हिच इज अ लीनियर कॉम्बिनेशन ऑफ a and b, right? So it is 1 minus t times a plus t times b, right? So this is the vector. अब इसको इंडिविजुअली अगर आपको लिखना है तो आप कैसे लिखोगे? What is x vector here? It is x1, x2, x3, because this is a three-dimensional space. We are in R3, right? Similarly, 1 minus t would be a real number. A को कैसे लिख सकते हैं? A1, A2, A3, right? And similarly, we can write b as b1, b2 and b3, right? So from here, you can see that x1 has to be equal to 1 minus t times a1 plus t times b1, right? Can you see that? Similarly, x2 has to be equal to 1 minus t times a2 plus t times b2, and x3 has to be equal to 1 minus t times a3 plus t times b3, right? So let's solve it. So x1 would be, what was the value of a we had? Uh, a was 1, 2, 2, and let me write it again here. So a was 1, 2, 2, and b was minus 1, 4, right? Minus 1, 4. So x1 here would be 1 minus t times a1, so 1 minus t. a1 here in this is 1 plus t times b1. b1 here is minus 1, right? Similarly, x2 would be 1 minus t times a2. a2 here is 2 plus t times b2. b2 here is minus 1 again. And x3 would be 1 minus t times a3, where a3 is 2, and then t times b3, and b3 is 4 here, right? So what do I get? I get this as 1 minus t, so which is 1 minus 2t, and here I get 2 minus 2t minus t, which is 2 minus 3t, and for this I would get 2 minus 2t plus 4t, which is 2 plus 2t, right? So this is what I get, right? So this is the equation of the line. So when in the paper, in the question, they ask you to find out the equation of the line, this is how you will state it. The equation of the line is when x1 takes a value 1 minus 2t, x2 takes a value 2 minus 3t, and x3 takes a value 2 plus 2t for any real value or for any real number t. This is what you will specify. This is the equation of line passing through A and B. Equation of line passing through vector A and vector B, right? So you can visualize it here. ये vector A है, this is vector B. इनके through जो line pass कर रही है, it is a linear combination of these two vectors, which is this line in red here, right? Which is this line in red here. ये जो line है red में, this is the line. Or if you want to visualize it in the three-dimensional figure that I've given you here, you can see that it is a line which is passing through the two vectors A and B, right? So it's a linear combination of these two vectors. So all the values of x which are a linear combination of A and B gives you the line passing through A and B vector, right? And this is how you will solve it, right? This is how you will solve it. So you will first write down the equation like this, and then when you open it up, you can see that x can be written as x1, x2, x3. A can be written as a1, a2, a3, and then these, and then you open these. This is what you would get. So this will give you the equation of the line, and you can find out the equation of the line here, right? Now the second part of the question says that where does the line meet the x1, x2 plane? x1, x2 plane is basically nothing but your, in this diagram, it is your xy plane, right? This is your xy plane. So what is the xy plane in this particular figure? ये आप फिगर देख रहे हैं जो ग्रे प्लेन है आपके पास, that is called the xy plane. So we have to find out the point where this line meets the xy plane. So you can see this point is somewhat here, जहाँ पे वो meet कर रहा है, right? So you can see it from here. So if I rub this x vector from here, you can see it that this is the point where it meets the, so this is the point where it meets the xy plane. So can you see that at the junction of the xy plane, or you call it x1 x2 plane, the value of z is 0, right? So जो xy x2 plane होता है, x and y plane, or you call it x1 x2 plane, वहाँ पे z यानी third variable की value जो होती है, that is 0, right? So z has to be 0. So in this particular example, at the meeting point of the line with the x1 x2 plane, x3 has to be 0. So at the intersection of, let's call this line L. So at the intersection of L and x1, x2 plane, x3 has to be 0, right? We know the value of x3 is this 2 plus 2t. So let's put 2 plus 2t as 0. So I get t as minus 1, right? So I get my t as minus 1. And then when I put in the values of t in my x1 and x2, x1 would become 1 minus 2t is I've got minus 1. So it becomes 3. X2 would be 2 minus 3t and t is minus 1 again. So it would become 5. And x3 you have already said that it is equal to 0. So I've got all the points. x1 is 3, x2 is 5 and x3 is 0. So the point where it intersects, the line intersects the x1 x2 plane is 3 comma 5 comma 0. Point of intersection is 3 comma 5 comma 0. I hope you are able to follow this, right? So we've seen it visually that what does it mean, right? So this is how you will find out the equation of a line. Now keep in mind पेपर में आपसे दो तरीके से पूछ सकते हैं इक्वेशन ऑफ लाइन. एक तो आपको दो वेक्टर्स दे देंगे या दो पॉइंट्स दे देंगे जिनके थ्रू लाइन पास करती है, उसकी इक्वेशन निकाल के दिखाओ, जो क्वेश्चन अभी हमने किया है, राइट? तो इसमें उन्होंने आपको पॉइंट ए दिया, पॉइंट बी दिया, और यू कैन कॉल देम वेक्टर ए एंड वेक्टर बी, एंड दे आस्क्ड यू टू फाइंड आउट द इक्वेशन ऑफ द लाइन दैट passes through these two vectors. Another way in which they can ask you the equation of a line is they will give you a vector and then they will give you the direction in which you have to find out the line, right? So let's look at what we are saying here. So this is type 2. So type 2, equation of a line, right? Here what we are saying is now we have to find the equation of line L. Let's call that line L. Equation of line L, which is passing through a point A, passing through a point A, right? Passing through a point A, and that A is say A1, or let's say passing through the point P, right? For uniformity with your book, let's call it passing through the point P, where P can be P1, P2, P3, right? So here we are dealing with the R3 plane, right? So passing through a point P and has the direction of vector A, right? Where A is say A1, A2, A3, then what is the equation of that line? So let's see what does it mean graphically. Geometry में देखते हैं इसका मतलब क्या है. What are they trying to say here? So suppose आपके पास एक plane है, that is the XYZ plane, right? We are in three-dimensional. So XYZ plane, right? We have a vector A here with us. Suppose एक vector है passing through the vector P. So we have a vector P here, right? And then we are given that there is a vector A as well, right? And the direction of the vector is this, right? So I have a vector P, right? This is my vector P, and then I have another vector A, and the vector A defines the direction for me. Now they are asking me find out the equation of a line that passes through vector P. So what is vector P or point P here? This is point P, right? It passes through this point and in the direction of vector A. So जो equation होनी चाहिए line की जो direction है, right? So the direction of the line should be this. The direction has to come from A and it should pass through the point P, right, which is coming from vector P. Now how will I find the equation of such line? So you can see that equation of this line would be, suppose I can write it as x. The equation of the line would be x such that P plus T times A. So what we are trying to say here is, suppose I have to find out the equation of this line. The equation of this line would be the set of all those x's, which is P plus T times A. Suppose, and this is for any real number T, right? For any real number T. So what does it mean? Let's see. Suppose T takes a value 1, right? suppose t takes a value 1, then what would I leave? If t is 1, then x would be equal to p plus a, right? So x would be equal to this. So let me use another color. So x would be equal to this, p plus a, right? So this would be my x. So that is 1 point on the line. If t takes a value half, then I would be somewhat here. So my x would be this. So this is 1 point on the line. If t takes a value 0, then in that case I would be at point P, right? So that the x would be this, right? And so on. If t takes another value, suppose I would be here, and so on. So this is the equation of the line that I want, right? If t takes a value 2, then I am in the same direction of a, but twice of a, right? So I'm adding twice of a to p, which would be somewhere. So double of this would be somewhat here. So I am here, right? So my x would be here in that case, right? So this is how I will trace out the line which is passing through point P and in the direction of vector A, right? Passing through point E in the direction of vector A. So this is how you can visualize it, right? Okay. So this is how you will get the equation of your line. So let me rub it for you, the extra things, right? So this is your vector P. This is your vector A in which you want the direction in which you want, and this would be the line, right? This would be the line L, and the equation of the line would come from this equality, right? So the equation of the line would be all those x's, all those vector x's which satisfy this particular equation. That is, you're adding t times a to your vector p, right? Where a is the direction in which you want the line, and p is the point through which the line should pass, right? So the equation of the line passing through point P and has the direction of vector A has the equation this, right? Has this equation. So let's try to do one question based on this, right? Let's do a question. So this is a question from exercise 12.5, question number 1, part B, right? It says find the equation of the line that passes through, find the equation of the line that passes through a point 132 and has the same direction as 0, -1, 1, right? So देखो अब इस केस में हमारा p क्या है जिसके थ्रू पास करना है, दिस इज पॉइंट p एंड जो डायरेक्शन है दैट इज कमिंग फ्रॉम वेक्टर a, right? We have already seen that the equation of the line would be, so it will be all those x's such that p plus t times a for any real number t, right? Now since we are in the three-dimensional figure, this x can be written as x1, x2, x3 is equal to p1 plus p2, p1, comma p2, comma p3 plus t times a1, a2, a3. So from here you can see that x1 would be equal to p1 plus t times a1, x2 would be equal to p2 plus t times a2, and x3 would be equal to p3 plus t times a3, right? Now what is p1 here? P1 is 1 plus t times a1 is 0, right? So this is nothing but 1. P2 here is 3 plus t times -1, so which is 3 minus t, right? And x3 here would be P3, which is 2 plus t times 1, which is 2 plus t, right? So this is the equation of the line that passes through point P, which is 1, 3, 2, and has the direction of the vector A, which is 0, -1, and 1, right? So this is the equation of the line. This is how you will state the equation. It is a set of all the points where x1 takes the value 1, x2 takes the value 3 minus t, and x3 takes the value 2 plus t for any real number. So we have to mention this as well. For any real number t, right? At the end of the answer, you have to mention this as well, right? So with this, we have found out, we have seen how to find out the equation of a line. There are two methods that you have to keep in mind. पहले मेथड में आपको दो पॉइंट्स दिए होंगे जिसके थ्रू आपको लाइन की इक्वेशन निकालनी है, राइट? उस केस में आपको क्या करना है? उस केस में दिस इज द फॉर्मूला that x, the line would be all those the set of all those x's such that it is a linear combination of a and b. The formula for it would be 1 minus t plus times a plus t times b, where for any real value, real number t, right? So this is when the line passes through two points a and b. The second type of question that can be asked is to find the equation of a line L that is passing through the point P and has a direction of the vector A. We have visualized it here that if it is passing through point P right here and it has a direction of this vector, then the equation of the line would be all those x's such that P plus T times A, right? And then we have seen a question also on that, how to solve such questions, right? So this is about the equation of lines. Then you can be also asked to find out the equation of a plane, right? Before learning how to find out the equation of a plane, I would like to introduce a topic called hyperplane to you. So let's see what is a hyperplane. Okay, so hyperplane is any flat, so it is, so I'll write down the definition for you first and then let's see what is it. So it is a flat n minus 1 dimension subspace within an n dimensional space. So what does it mean? Suppose we are in a two-dimensional space. Two-dimensional space क्या होता है? XY plane, right? Suppose we are in a two-dimensional plane. ये x axis है, ये y axis है. Two dimension है ये. This is 2D. This is R2, right? We will call it R2, two-dimensional space. Now a hyperplane here in a two-dimensional space. So अगर we are in a two-dimensional space, the hyperplane here is a flat surface which is one dimension less than this space, right? So यहाँ 2D है, so any flat surface or any flat one dimensional figure is a line. So in a two dimensional figure, line is a hyperplane. So if you draw a line, the dimension of the line is only, so we have just one length. A line only has a length, it does not have a breadth. So this is one dimensional, right? So for a two-dimensional space, which is xy plane, line is a hyperplane. If we are talking about a three-dimensional subspace, three-dimensional space, right? जहाँ पे x axis है, y axis है, z axis है. In that case, the hyperplane would be a plane, right? Because you can see that a plane. Suppose this is a plane. You can see that a plane has. अगर ये एक plane है, right? If this is a plane, then it has two dimensions. It has a length and it has a breadth, right? You can see that it has a length and this is the length of it and this is the breadth of it. So there are two dimensions to it. So in a three-dimensional space, a plane is a hyperplane, right? So in R3, which is three-dimensional space, a plane is a hyperplane, right? What is the use of a hyperplane? A hyperplane divides the entire space into different parts, right? तो आप देख सकते हो यहाँ पे जो लाइन है ये पूरे XY plane को दो हिस्सों में डिवाइड करे. Similarly, this plane will also divide my entire space into into two different parts, right? So that is the definition of a hyperplane. Here we'll be dealing with first. So we have done the three-dimensional space and found out the line for it. Now in the three-dimensional space we are trying to find out the equation of the hyperplane, and in the three-dimensional space the hyperplane is nothing but the plane, right? A two-dimensional plane. So here we'll be talking about the equation of a plane, right? So let's see how to find out the equation of a plane. उससे पहले सपोज हमारे पास एक थ्री डायमेंशनल फिगर है, राइट? और उसमें एक प्लेन है P, राइट? So let me show it to you here with the help of a figure that I have drawn for you, so you can visualize it from here. You can see that this is the x axis in the red, जो red में है, that is my x axis. In the red I have my x axis here. In green I have my y axis, and in blue I have my z axis here, right? This green thing is a plane I have. तो आप देख सकते हैं, this is a plane that I have, right? Now this thing in yellow is a vector A or a point A that lies on my plane. तो मेरे plane पे एक point lie करता है A, right? And this is the vector A. तो vector A yellow में जो है, this is a vector A, right? Now this line black which is passing through it, it is called the vector P, or it is also called the normal to the plane. Normal मतलब एक ऐसी लाइन और ऐसी लाइन जो कि ऑर्थोगोनल है मेरे प्लेन को, उसको बोलते हैं नॉर्मल टू द प्लेन, राइट? सो यू कैन सी दैट दिस P हियर, राइट, ये जो P है, this P here, this is the perpendicular to this plane, right? ये जो P है ये इस पूरे plane पे perpendicular है. So equation of plane निकालते टाइम the type of question they will ask you is they will give you this point A. वो आपको बता देंगे कि आपके पास एक point A है जो कि उस plane पे lie करता है, यानी आपका plane उस point A के through pass करता है, right? And then they'll give you the normal to the plane, or they will give you the perpendicular, that is perpendicular or the orthogonal line to the plane की जैसे P दे देंगे आपको, they'll give you a vector P which is orthogonal to the plane or which is perpendicular to the plane, and then they will ask you to find out the equation of the plane, right? So in order to find out the equation of the plane, what you have to do is, first of all you have to describe this vector A here. We've described the vector A here. Then you would say suppose there is a vector x, कोई एक vector x है जो कि which is also lying on the plane. Let's call this plane P. So this is how you will write the plane here. This P here stands for the vector. ये वाला जो P है, this is the vector here, and this P, this is how we denote our plane P, right? So this is my plane P. Now this vector x also lies on my plane P. Now we are saying since this वेक्टर P इज नॉर्मल टू द प्लेन, यानी ये परपेंडिकुलर है प्लेन पे, तो प्लेन के अंदर जितने भी वेक्टर्स लाई करते हैं, प्लेन के ऊपर जितने भी वेक्टर्स लाई करते हैं, ये उन सब के परपेंडिकुलर होगा, राइट? सो इफ आई टेक a point A here, I take another point C here, right? And I call this vector, this blue vector, as vector x. Then this pink vector which is going from A to C will be the vector x minus A, right? So this will be vector x minus A. So if I have, initially I'm given the point A here, right? And then I take any vector x which is which is the point C on the plane, right? Then this vector joining A and C, which is a pink vector, would be x minus A. Now since this vector P is perpendicular to my plane, this P is also perpendicular to this vector x minus A, राइट? अगर मेरा वेक्टर P पर प्लेन के परपेंडिकुलर है, तो इस प्लेन में कोई भी वेक्टर जो लाई करता है वो उसके भी परपेंडिकुलर होगा, इस प्लेन में जो भी लाइन लाई करती है उसके परपेंडिकुलर होगा P, राइट? सो आई हैव ड्रॉन सच लाइन x minus A, right? I've got this line x minus A with the help of vectors x and A, right? A was already given to me in the question. Since P is perpendicular to this vector A, this P vector is perpendicular to vector x minus A. We had seen in the last class the condition for orthogonality was that if two vectors are orthogonal to each other, then their scalar product is always equal to 0. Then the scalar product x minus A times P should be equal to dot P should be equal to 0. This equality will help us to find out the equation of our plane P, right? ये जो बड़ा वाला P है, bold P, that is the plane P, right? Plane को denote करने के लिए we are writing it in bold P, right? So equation of the plane निकालने के लिए हमें क्या क्या चाहिए? We need two things. First of all, we need the point through which the plane passes, and here we are denoting it by point A, right? And then I need the equation I need the vector P which is normal or which is orthogonal to my plane, right? And I know that if P is perpendicular to the plane, it would also be perpendicular to any vector lying on the plane or any line lying on the plane. So here I have constructed such line with the help of vector x. तो मैंने एक vector x लिया, right, which goes from B to C, which goes from point here, which origin to point C on the plane, right, and then I know that from point A to point C this would be vector x minus a, and it lies on the plane, right. So this this vector p should be perpendicular to this vector x minus a as well. And making use of the orthogonality condition that we had seen in the last class, that two vectors which are orthogonal to each other, their dot product should be 0. I can write that x minus a here, dot product with p should be equal to 0, and this condition would help me to find out the equation of the plane. I hope it is clear to you from this particular diagram. So let's write it down formally, how to find out the equation of a plane, right? So we are finding out the equation. Let's use another color pen. Equation of a plane, right? So let's define our vectors first, or our points first. Let us consider a plane P. So this is how I am writing the P, which stands for plane. So P, plane P in R3, right? So the entire space for us is R3, and the subspace here would be the plane, right? So P passes through A. We know that this plane P passes through point A. So यानी A जो है वो एक point है plane में, passes through A, which is vector A, and then vector P is perpendicular to, or you also call it a normal to, is perpendicular to the plane P, right? Then this implies that P, this vector P, will be perpendicular to any line, है ना? अगर वो पूरे plane के perpendicular है, तो it has to be perpendicular to any line in the plane, right? Plane में जो भी line होगी उसके भी वो perpendicular होगा. Now हम मान लेते हैं कि मान लो x भी एक point है. If x is a point in plane P, right? This all I have just explained it to you अभी. I'm just writing it formally for you. अगर x भी एक point है plane P में, then we have seen that then P would be perpendicular to x minus a. This we have just seen, right? So let me show it to you again. तो अगर ये हमारा plane है, right? This is our plane. This is our plane. इसमें एक point A है, right, which is this vector A. I have another point x, which is this vector x. Then this vector x minus A would be perpendicular to the vector P here, right? So since this is the case, so I can say that. So now I can say that x minus A dot product would be with P would be equal to 0, right? So now let's try to simplify it. अब देखो x क्या है हमारे पास, since we are in R3, x would be x1, x2, x3, right? And A would be A1, A2, A3. Dot product with P, and P here is P1, P2, P3, and it has to be equal to 0, right? So this is nothing but x1 minus a1, x2 minus a2, and then x3 minus a3. Dot product p1, p2, p3 has to be equal to 0. In the dot product, I multiply the corresponding elements. So this component would be multiplied with this, then add to it this multiplied with this, and then add to it this multiplied with this, right? So what we're saying is x1 minus a1 into p1 plus x2 minus a2 into p2 plus x3 minus a3 into p3 is equal to 0, right? When I open the brackets, I get P1 x1 minus P1 a1 plus P2 x2 minus P2 a2 plus P3 x3 minus P3 a3 is equal to 0. Now simplifying it further, I can write down the equation of my plane as P1 x1 plus P2 x2 plus P3 x3 is equal to, I can take all the P1 A1 PA terms to the other side. So I get P1 A1 plus P2 A2 plus P3 A3, right? So this finally is the equation of my plane. This is called the equation of plane, right? Where the equation of the plane is P1 x1 plus P2 x2 plus P3 x3 is equal to P1 a1 plus P2 a2 plus P3 a3, where P1 P2 P3 are the normal or the perpendicular to the plane, and a1 a2 a3 are is the point through which the plane passes, right? Always note or keep in mind, तो जो x1 x2 और x3 के जो coordinates है, it will give you the vector which is perpendicular to the प्लेन P, राइट? तो अगर आपको प्लेन की इक्वेशन दी हुई है क्वेश्चन में, तो आप x1 x2 x3 के कोएफिशिएंट्स को देख के अपने नॉर्मल वेक्टर का पता लगा सकते हो, राइट? वील डू अ क्वेश्चन, व्हाट आई एम सेइंग, वील डू अ क्वेश्चन बेस्ड ऑन दैट इज देयर इन योर एक्सरसाइज आफ्टर दिस. So first let me do a simple question. Let me do a question with you, which says, or an example, which says find the equation of the plane, find the equation of the plane in R3 through, so they are given through P, so through the equation has to be through A, right? Through A, which is given to you as 2, 1 and minus 1, and then with P as the perpendicular or the normal, which is minus 1, 1 and 3 as a normal, right? This is the type of question they can ask you. Equation nikalo plane ki R3 में, which is passing through the point A and which has a P, which is this minus 1, 1 and 3 as a normal. So you've already seen the equation of the line, equation of the plane would be, let's do the solution. Equation of the plane would be x minus a dot product with P should be equal to 0, right? Here you will write it as x1 minus a1, a1 is 2, comma x2 minus a2, and a2 here is 1, comma x3 minus a3, and a3 here is minus 1, so it will become plus 1, dot product with P, which is minus 1, 1 and 3 should be equal to 0. When I take the dot product, multiplying the corresponding elements with each other, I'll get minus x1 plus 2, and then plus I multiply x2 minus 1 with 1, so I get x2 minus 1, and then plus I multiply 3 with x3 plus 1, so I get 3x3 plus 3 is equal to 0, and taking all the x terms, x1, x2, x3 terms on one side and the constants on the other side, I get minus x1 plus x2 plus 3x3, right? And solving this, I will get 4. So plus 4 is equal to 0. So I can take it to the other side. I get minus 4. So this is the equation of the plane that I will get. Now, the trick that I had told you, you can see the coefficients of x1, x2, x3 here. The coefficient is minus 1, 1 and 3, and you can verify it here from P that is given to in the question, that the coefficient of x gives you nothing but the vector P, or the vector which is normal to the plane, right? So this is just a trick that will be useful in certain questions that we'll be doing later. Now let's do one more question, which is question number 4 from your exercise 12.5, right? The question says, show that a is equal to minus 2, 1 and minus 1 is a point in the plane minus x plus 2y plus 3z is equal to 1. So you're given the equation of a plane और आपको एक point भी दिया हुआ है. This is the first part of the question, A part. You are given a point and you are given a plane. You have to show that this point actually lies in this plane. तो अगर कोई point उस plane में lie करता है तो all the coordinates should satisfy the equation of the plane. यानी x coordinate की जगह अगर मैं -2 डालूंगी, y की जगह मैं 1 डालूंगी और z की जगह अगर मैं -1 डालूंगी, then this equation should satisfy. Only then I can say that this point A would lie in the plane, right? Would be there in the plane. So substituting A for x, y, z, a1, a2, a3 for x, y, z in the equation, let's see. So solution, putting point A, okay, putting point A in the equation of the plane. Let's see. So in place of x I will write -2, so minus of -2. In place of y I will write 1 and in place of z I will write -1. Let's see what do I get. I get 2 plus 2 minus 3 which is equal to 1, which is what is there in the RHS. So the equation of the plane is satisfied. Equation of plane is satisfied, right? With this particular point, so we can say that this point actually lies on the plane, right? Then the B part of the question says, find out the equation for the normal at point A to find out the equation for the normal at point A to the plane in part A. तो जो आपका पार्ट ए है इसमें जो आपको प्लेन दिया हुआ है यानी दिस प्लेन, इस प्लेन के परपेंडिकुलर एक जो आपका नॉर्मल है उसकी इक्वेशन निकालो सच दैट दैट नॉर्मल शुड पास थ्रू पॉइंट ए, राइट? तो जो भी आपका प्लेन है, सपोज दिस वाज माय एक्स वाई एंड जेड, राइट? आई हैड अ प्लेन लाइक दिस. सपोज मेरा प्लेन कुछ ना कुछ ऐसा दिखता था, राइट? दिस इज हाउ माय प्लेन लुक्ड लाइक. So suppose my plane looked like this, right? Now we are saying that there is a point A on my plane. So suppose there is a point A, right? And the vector is given to me. I have to find out the equation of the normal at this point. तो मुझे ये equation निकालनी है, right? This is point A or this is point. This is how I will get point A, right? This is A, point A, and this is the vector A I am given, right? Now I have to find out the equation of the line, this line, which is perpendicular to the plane at point A, right? So पहले तो देखते हैं कि नॉर्मल क्या है हमारा यहाँ पे. मैंने आपको बताया था जो नॉर्मल वेक्टर है पहले वो आपको पता होना चाहिए. नॉर्मल वेक्टर कैसे निकालते हैं हम? We will look at the coefficients of the x, y and z in the plane equation of the plane. तो आप equation of the plane अगर देखते हो तो x का कोऑर्डिनेट इज -1, y का कोऑर्डिनेट 2 है और z का कोऑर्डिनेट 3 है. तो परपेंडिकुलर वेक्टर क्या है? बेसिकली हमारा परपेंडिकुलर वेक्टर p इन दिस क्वेश्चन इज इट इज -1, 2 and 3. सो इज दिस क्लियर, राइट? क्योंकि ये क्या है? इक्वेशन ऑफ द लाइन है, प्लेन है, और इक्वेशन ऑफ द प्लेन हमने देखी थी क्या होती है? p1 x1, राइट? तो यहाँ पे x y z है तो p1 x p2 y प्लस p3 z इज इक्वल टू p1 a1 plus P2 A2 plus P3 A3, right? तो अगर P1 P2 P3 की वैल्यू -1, 2 और 3 है, if you multiply it with A1 A2 A3 you will see that you will get 1 only, right? So here your P1 P2 and P3 in this question is -1, 2 and 3. So now you know that the direction of the vector in which you have to go is -1, 2 and 3, right? The point A that is given to you in the question is -2, 1 and 1, right? Point A is -2, 1 and -1, right? So you have to find out the equation of a line that passes through point A in the direction of vector P. यही करना है ना हमको नॉर्मल की इक्वेशन निकालनी है एट पॉइंट ए. नॉर्मल की इक्वेशन क्या है, हमें पता है नॉर्मल वेक्टर क्या है P. हमें उस लाइन की इक्वेशन निकालनी है जो पॉइंट ए से पास करती है इन द डायरेक्शन ऑफ द नॉर्मल P. P की डायरेक्शन में. सो यू नो इक्वेशन ऑफ लाइन passing through A in direction of P would be, what would it be? It would be, yes, tell me, it would be all those x's such that passing through A, तो A में add करेंगे t times P क्योंकि direction क्या है P, right? So x1 would be A1 plus t times P1, and this is for any real t. X2 would be A2 plus t times P2, and x3 would be A3 plus t times P3, right? A is given to you as, so इसमें values डाल देते हैं. A1 is given to you as -2 plus t times P1 is given to you as -1, so you get -2 plus t. Right? Similarly, A2 is given to you as 1 plus t times P2 is given to you as 2, so you get 1 plus 2t. Right? Similarly, x3 के लिए A3 is given to you as -1 and plus t times P3 is given to you as 3, so you get 1 minus 3t. So this is the equation of the line, this entire thing. This is the equation of the line that passes through point A and is normal to the plane passing through point A. Right? So this is what the question. Find out the equation for the normal at point A to the plane in part A. Right? So this is how you will do such type of questions, right? So I hope you're able to visualize what is a plane, what is a line. We are here, we have increased our scope. Earlier we were there operating in the two-dimensional space, but now we have expanded our horizon. We have come to a three-dimensional space, and we can generalize all these results to a to more dimensional planes as well, more dimensional spaces as well. So we can go to 4-dimension, 5-dimension, and up till n dimensions, right? So here it was easy for you to visualize the three-dimensional plane. That is why we have done it in a three-dimensional plane. But then you can generalize it three-dimensional space. But then you can generalize it to an n-dimensional space as well, right? So I hope this video was helpful for you and you were able to get the concepts. We have tried to do it graphically as well. We have done some questions from the exercise as well. If you want me to solve any other question from the exercise which you are not able to tell, you can just write it in the comment sections below, right? Okay, thank you. Thank you all for attending the class. Have a good day.